The MoneroTopia guest segment is sponsored by Cake Wallet. Store, send, receive, and exchange your Monero and Bitcoin safely on iOS and Android too. Cake Wallet is open source, and you always control your own keys.
Alrighty, Luke, can you hear us?
Yeah, hello.
How's it going, man? Long time.
Thanks for jumping on.
Yeah, happy to. It's going well. It's been a bit. Stepped back some months ago, definitely decreased how much I contribute to the project since, but recently I've been getting a bit more and more involved with some of the discussions again.
All right, it's pulling you back in, man. The Monero saga continues, right? It's never boring, right? At least Monero has that going for it.
Right.
So
yeah, where should we start?
What are you? Yeah, what has pulled you back in here? Why are you looking to contribute again to Monero? I mean, what do you see as being the issues here?
Well, I mean, I've always been around, and occasionally commenting. I think what got me into this topic so actively and started commenting on 51% issues was just how annoying all of the posts were. Because there were a lot of posts and they were just like, oh, do we have to be concerned about this? Do we have to be concerned about this? And personally, it was to such a degree, I don't think that they were legitimate. I think people were just trying to say, oh, do we have to be concerned about this? To try and raise attention, but not raise attention as an issue, but as a promotional campaign. I mean, I believe almost all of this is a marketing campaign for another project, which is just attempting to parasite off of Monero in that regard. Go ahead.
And so even that being what it is, and even if you are correct, is that still an issue though?
I believe even by their own claims, they've only achieved 40% of hash power, which is definitely concerning and is a very scary number. But part of the great thing about that is if they have 40% of hash power, well, that means you can consider it as they have 40 units of hash power to the rest of the network's 60 units. In order for them to gain 50% control, not even 51%, just 50%, assuming that they aren't stealing miners, assuming miners are quote unquote switching sides, they would still have to increase their hash power by 50% to go from 40 units to 60 units. That would be 50% more hash power on their end, which is still a very large amount. Like, I don't think that they've demonstrated that they can 51% attack the network. I don't believe that is an immediate risk, but I believe that they've once again raised the discussion on how secure is proof of work and what are all of the issues and trade-offs with it, which is why we have this GitHub issue in front of us, which goes over the various alternative proposals we could consider and what those might look like in order to encourage discussion. Not because the knee-jerk reaction is, oh, proof of work is broken, we have to move immediately, run! But because if we can do better, we should always try to do better. And we don't know if we can do better if we aren't considering all of the options. So that's what this GitHub issue is. It's just spurred by recent events to discuss potential options. And at the very bottom of the issue, in my first post, is even the option, do nothing. We can just keep using proof of work. We can just improve the existing code base to be a bit faster and a bit more responsive and a bit less vulnerable to certain optimizations, annoyances, attacks, exploits, whatever you want to call them, that attackers can take advantage of or bad actors can take advantage of. But we don't have to change anything at this time. It's not like the network has actually been captured or is actively under attack. It's just always, how can we do better?
And I love that, right? I do think that is the silver lining here, and I love that the Monero community is appropriately responding. And I love that it pulled you in, and you're jumping in here because you want to make comments on this topic and help steer Monero in the proper direction. So what is your current take then? So given this list, and we'll get into all of them. I would like to get into all of them if we can, but let's just get right to it. Where do you stand here on this list? Are you of the mind? It sounds almost like you're just saying that you would kind of vote for let's just keep things the way they are. Perhaps add some efficiencies like you're saying, but proof of work is working. Is that where you currently are?
No, I definitely wouldn't say that.
Okay.
I think there's two very notable proposals on the list of so far accumulated, and that would be adopting a Byzantine fault-tolerant finality layer, which is the second proposal there, along with the old issue created by Tevador on requiring miners to run a full node.
Okay.
If you scroll down, it's the other one that has a link to it. Yes, that one.
Is that the one that Sec 1 also was talking about, or that's different? Where he was saying
No, Sec 1 was proposing miners have to sign their blocks. So if I'm mining to a pool right now, I just run a Monero miner, and the pool tells me which block to mine.
Mm-hmm.
But if I have to sign the block, and specifically the most common version of the proposal I've seen discussed is that I have to sign the block, which means I have the private key that is signing the block because I have to do the signing process. And yes, I could send the block hash to the mining pool, and they could send back the signature, and I could check if it's beats the difficulty and is a successfully mined block, but that would use far too much bandwidth. So practically, you have to locally sign it and locally have the private key. And then for whatever private key signs the block, they have to get 10% of the block reward. So this means that whoever the miner is definitely gets 10%, and that further encourages solo mining, because solo mining is completely unaffected, but pools prior expected to capture 100% of the block reward. Now they're only capturing 90% of the block reward, and they're less profitable. I don't like that proposal because I think it's too easy to avoid and get around. But I do appreciate this old issue by Tevador on requiring miners locally run a node, because I do believe initially, I reviewed this, a year ago, and I didn't really think much about it. I forgot it even existed. And then I was reminded of it this morning, so I can't speak too much on it. I'm not here to say, oh, this is the path forward and this is great and perfect. No, we still have to have a discussion and properly consider it and fairly evaluate it.
Can I ask a question really quick before you move on to the running a node? So if you're going to penalize miners, would that also affect P2Pool, or would that only affect like larger centrally managed pools?
If you had to sign your own blocks, that would also affect P2Pools, because P2Pool would now only get 90% of the block reward, and whoever actually found the block would get 10%.
Is there any way to financially incentivize exclusively P2Pool in somewhat diminish centrally managed pools?
Well, that's what I was kind of getting to, is that if you have to run your own node via the method Tevador proposed, and at initial glance, I do believe Tevador's proposal would work and make sense. Well, now if miners have to run their own node, there's no reason not to use P2Pool. So that likely, I think it would promote P2Pool and get more people to switch over, because there's no longer a barrier to entry, because every miner already has to satisfy its requirements.
And so, just from my understanding, how would this come into play with the attack we're seeing from Cubic? This is more of a getting more people to use P2Pool, not necessarily.
Well, it's disincentivizing mining pools and requiring that miners run Monero nodes. So if any service is renting random X hash power, it could no longer be targeted for Monero, because you can no longer have random X hash power. You also need a Monero node, and someone would have to not sell random X hash power, but they would have to sell random X hash power plus a Monero node that was able to keep up to date with it. It would likely further encourage usage of P2Pool, but it doesn't. This was proposed 3 years ago, and it wasn't proposed in response to the fact we currently have a mining pool that is not well contributing to the network and is making threats against it. And it was not proposed in response to this. And that's where this proposal gets tricky. Because yes, it promotes miners running their own nodes, it disincentivizes pools, and it promotes P2Pool. But at the same time, we may have existing miners who no longer participate if they simultaneously have to run a Monero node, depending on the requirements. Because if they have an entire mining farm and they just have to add one computer with a Monero node, I don't expect that would be an issue. But if you're an at-home miner who's mining Monero because you want to support the network, and we now require that you give up 120 gigabytes of disk space to run a Monero node, you might not have 120 gigabytes of disk space. So even if you want to mine and support the network, and even if you're currently doing that via a centralized pool, which probably is still better than, it is still better than nothing, you know? If you're mining to an honest pool that has a minority of hash power, that's better than not doing anything at all. But those people, if they now also have to run a node, they may stop contributing their hash power. Whereas I don't know what miners the cubic mining pool is composed of, but they may entirely be willing to run Monero nodes as necessary for this proposal. So it would shift hash power, and that's the question. Does it shift hash power in favor of miners who want to well contribute to Monero, or would it shift hash power in favor of our current adversary? Because the design goals, if it are good, and 3 years ago it made sense, but as we discuss it now, there's this very realistic and practical issue where there's one mining pool with such a large amount of hash power, even if they have yet to get 51% or close to it.
So out of all these proposals, if one were to be implemented tomorrow, which one would have, you know, the strongest effect against what the current attack we're seeing with Cubic?
Oh, I think definitely the finality layer.
Okay. And that's your top choice right now?
Well, I wouldn't say that.
I know there's always nuance.
I mean, if we're discussing the current issues with mining pools, the finality layer would be the utmost solution for it. Because the interesting thing about the finality layer is that if it's sufficiently quick, if it's able to reach consensus every couple of minutes, which isn't unreasonable, it's very likely, it could prevent selfish mining. Selfish mining is where an adversary with a minority of hash power, less than 51% of hash power, but still enough hash power that they can successfully perform this attack, is they will mine a block, but they won't publish it. Because if they publish the block, everyone else will start mining on it. Instead, they just mine a block, they don't publish it, but then they start mining the block after it. So now everyone else is trying to mine, you know, block 100, but this mining pool, which is keeping its blockchain secret, is already mining block 101. And the reason for that is now with all of the other mining pools finally mine block 100, but a minute later, the secret mining pool mines block 101, they'll immediately reorganize to this block 101, and the mining pool which mined in secret will get 2 block rewards instead of only 1, because it kept insider information.
Okay.
So the reason this finality layer, if it was sufficiently quick, would stop selfish mining is because as soon as any block hit the network, it could potentially finalize it. So if you withhold a block or a set of blocks, those will no longer be seen by the finality layer, and the finality layer may finalize some other block. So even if you're selfish mining, and even if you mine a chain with more work in secret, the finality layer can say you didn't publish these in time, they weren't finalized, we're not moving to them. The finality layer would also stop deep reorganizations. It would immediately enable replacing the 10 block lock with a finality block lock, where
I think I like that. Go ahead.
Right. Instead of waiting for 10 confirms, you just wait for the block to be finalized. And once it's finalized, all of the outputs within it would be spendable. And if the finality reaches...
What determines reaching finalization?
Just 1 second, and I'll get there. But
okay.
If the finality layer is quick enough, that could just be a 1 block lock. And if it was just a 1 block lock, in practice, we can just remove it at that point.
Oh my God, amazing.
So finality would be determined by the finality layer, which would be a dedicated group of validators who observe the proof of work blockchain. And when a proof of work block is mined, they would vote on it and issue a finalization. As for how we would select validators for this finality layer, we would presumably use some form of stake. And there are multiple definitions of stake possible, but in my opinion, the only reasonable definition is Monero. People stake Monero, and that is the basis of the finality layer. Now, the concern there is, of course, we don't know how much Monero exchanges have. And we don't know how much Monero, people from 10 years ago have, and we don't know the distribution of Monero. Because guess what? It's a privacy coin. We can't see any of that. So, as I was saying, with the proof of work proposal, where you have to run an existing Monero node, we don't immediately know how that would shift hash power. We just know it would shift hash power. At the same time, with this proof of stake finality layer, there's a lot of benefits. But we don't know exactly who would become the validators. And it would be very interesting to play out the fact that we have validators, but we can never actually observe them because the entire origin, source of funds, actual amounts is completely private thanks to Monero.
Hey, maybe the exchanges would stop fractionally reserving Monero in that case, finally.
Well, if we did have a finality layer, we would require actually staking Monero. So if an exchange did stake their Monero, they may not be able to facilitate withdrawals because the Monero they're staking could be time locked.
Yeah.
I mean, something like that would definitely create upward pressure on the price as well, which, whether or not you care about price, obviously that goes towards security as well, right? If you have a higher price, that arguably makes things more secure as well, right?
I'm not here to comment on if or how it would affect the price. That's not my field. I'm not a financial advisor. Go talk to your own about that.
Well, from a technical standpoint, right? If people are staking and holding, it's forcing holding, right?
Please go talk to your own financial advisor.
Maybe
I am not one. This is not financial advice.
Body's our token financial advisor. Body, please.
Don't worry. I got you.
I mean, price is part of the system, right? So, I mean, to ignore the fact that a price exists, I think, I understand you don't want to talk about it for legal reasons, but it is in fact part of the system of what Monero is. Body.
It's not just the legal reasons. I also do have to concede it's not my field of expertise, and I don't personally care that much.
Okay, but if price going up were to be in effect, that would also have a positive effect on the security of the network. Is that fair to say?
I mean, I guess so. Yeah, price going up is going to encourage more hash rate, right? So there'll be more security just for the proof of work aspect. Right. And then you get, if these exchanges and if these sort of institutions now have an incentive to not attack the network and they're going to get some sort of rewards, yeah, you could theoretically say that, or hypothetically say that, they're going to be more interested in helping to secure the chain as opposed to acting poorly. And yeah, I mean, maybe that gives them enough buy-in. I don't know.
Right, and then it also becomes more profitable to mine Monero.
Implementation details matter. Actually, Luke, I wanted to ask you, so if hypothetically there was going to be some sort of proof of stake in a lock time, aren't we getting rid of the lock time? Isn't that like one of the big things leaving with the next hard fork?
Yep.
So we kind of have to like either, would that have to get redesigned? Like, is the current locking mechanism not that great, and so it needs to be redesigned if we were going to do a finality layer?
Right. So, I'm so sorry if I didn't tell you about this before, but the finality layer would be a hard fork, and we would have to make changes for it. No, I'm joking. But yeah, the existing time lock mechanism, it's being removed for a few reasons. The first of all is that it's not private. I mean, that's a very obvious statement. If you put a time lock on chain, everyone can see the time lock. And that means that your transactions can be fingerprinted. That's less of an issue with full chain membership proofs because, with full chain membership proofs, you make one hop and you're completely fine again. But yeah, the fact that transactions can be fingerprinted is never great because that allows identifying, oh, well, none of these wallets allow you to make time locked outputs. So if this transaction exists with the time lock on chain, the user who published it must be using this wallet. And if we can somehow identify, what IP address published it, then we know like what wallet this household is using. Like there's all of these reasons that we always want transactions to appear uniform on the blockchain itself. The next issue was performance reasons. It was possible to create a bomb where you create like over like 1,000 blocks. You just fill each block with time lock outputs that all unlock on the exact same block. So now when we get to like block 1 million, instead of having, 1,000 blocks at 2 minutes each to add all of these outputs to the chain, when we hit block 1 million, we have to immediately add 1,000 blocks of output, 1,000 blocks of outputs to the database and process them all at once. And that just allowed, there is a risk where you can create so many time locked outputs, it takes more than 2 minutes to add them to the blockchain. Which would mean that it takes more than the block time to process a block, which is problematic. Then the other thing was, it was just complexity, and there was no like well-established use for time locks. The best use advocated was, what if I'm financially irresponsible and want to make sure I don't use my Monero early? There are other solutions for that. You don't have to use the on-chain time locks. There are cryptographic solutions for that. There are trusted setup solutions for that in the sense of, trusted execution environments by like Intel, AMD, ARM. There's probably a lawyer who will do that for you as a service. There's probably a safe you can bury underneath a tree. There's various other solutions. Like the complexity of the feature was not worth it for what minimal benefit it offered. Like it didn't benefit, say, atomic swaps at all. So I did make a GitHub issue to add a support for a payment channel network to Monero, where we would have to agree on a competent design and then make the relevant changes to support it. And as part of that, I detailed a new time lock scheme that was private, did not allow creating these, computational bombs where you could get a node to take several minutes to process a single block, and was of reasonable performance impact. I think it would have made every membership proof about 50% slower. And that's not great, but if it was necessary and offered sufficient benefit, it would be worth it. So we do have a private time lock proposal of acceptable performance impact we could adopt to facilitate the finality layer.
Nice.
Interesting. So like we could even see, hypothetically, if designed right, you could see an enhanced ability to do a payment channel network simultaneous with the finality layer. Like they might sort of overlap somewhat. Is that correct?
Yeah. Is it Tux you're screen sharing, or is it Doug who's pulling up the GitHub issues?
Tux.
Sorry, it's me. I'm screen sharing.
Yeah, Tux, would you mind going to the issues? I think it's going to be like 5th down on the MRL list. It's just going to be PCN. No, if you go to the actual research lab issues, like the full list of issues. Add explicit support for a worthwhile PCN design, middle of the screen.
That's interesting that making the time locks non-transparent consumes that much additional compute resources.
Well, my proposal for it was to embed it into the output. So right now, outputs are of the form of just a private key scaling a generator, which is a bastardization of elliptic curve cryptography terminology. Please forgive me. But basically, it's just a number times another number. With SCMP++, we're transforming outputs to be a number times a number plus a number times a number, where for all existing outputs, the second number is just 0, because, a number times a number plus 0 is equivalent to a number times a number. The way I propose time locks in this issue is just to add in a third pair of numbers, where now outputs are a number times a number plus a number times a number plus a number times a number. And with that, we could embed a time lock data or a time lock specification into the output. And when we do the membership proof, we can strip it out and verify that it's satisfied.
Going back to the list. So finality layer we just spoke about. So is that the only option you see that could potentially would get rid of the 10 block lock? In addition to obviously bolstering us against 50% attack.
I asked Tux to pull this up just because if they kept scrolling past all of the math, it did make it clear we don't just need a time lock for a PCN. We would have needed other features. This is just the first step of the puzzle. But if Tux does want to pull up the table again.
Tux, if you just go back to the table. I'm
sorry, we keep pulling Tux in a tug of war. Yeah. There's a dedicated column for allows reducing the 10 block lock. And the finality layer allows replacing it with the finality lock. And if that's sufficiently low, then practically we could remove it entirely. And then none of the others do, except one of them is labeled maybe, which is going to be checkpointing onto a larger network. Basically, every time we mine a Monero block, we could publish it to Ethereum. And then when you sync a Monero node, you sync an Ethereum node. And instead of looking for the Monero blockchain with the most proof of work, you look for the Monero blockchain first indexed by Ethereum with valid proof of work. So someone can make a larger proof of work blockchain, but you wouldn't reorganize to it because Ethereum would be used to say, no, this blockchain came later, do not reorganize to it. The first blockchain that was valid and existed is whichever one Ethereum saw first.
And so
I love and hate this idea.
Yeah, do you see
for this
that
reason
as,
exactly on the right?
It's strong, but yeah, fuck.
Well, I mean, it would still have to be a valid Monero blockchain. It just means that if Ethereum reorganizes, Monero does. But what are the odds Ethereum reorganizes? Am I right?
Yeah, that's a huge attack. You're not going to be able to attack both Monero and Ethereum simultaneously like that. I mean, okay, hypothetically.
Well, that's the thing. You just have to do any reorg because you don't need the longest proof of work Monero chain. You just need a valid proof of work Monero chain.
So, Luke, what is your overall take on that option? Do you see that as a
No, I don't think we're ever going to adopt it. I don't think the community is ever going to support syncing a 1 terabyte Ethereum node in order to use Monero. I believe the community believes itself to sovereign and independent and ideological to move forward with that. And I don't say that to be dismissive or rude. I just say it very factually. I don't believe the Monero community at large would want to give up its quote-unquote sovereignty. It's why I said in the issue, it makes us a quote-unquote vassal to the Bitcoin or Ethereum empire, because it would be replacing our consensus. Yes, if the Monero blockchain decides what is a valid Monero block, but we would use Bitcoin or Ethereum to decide the best Monero block and be subject to their consensus.
In a
And I just don't think.
Yeah, it hurts us a lot. In a political sense, it hurts us a lot. Like you can already see the memes. Like it effectively declares, oh, we can't do it on our own. We need Bitcoin, and then just cue the maxis, right? Just pouring in.
Yeah.
Like it's not viable for us.
Even if we get past the political sense, but I don't think we have to. Like I think we can acknowledge this will never get political support because we'll never get political support unless one of us wants to fork Monero into a $0 weird 1 week old exchange only microcap. Like there's no point in discussing anything that won't be politically supported. That's the unfortunate truth about development in some communities. Is like even if you have great technical ideas, and while the community generally frequently goes for these great technical ideas, it's why we have these issues, there will be some ideas where even if you believe they are technically optimal, the community would rather die than accept them. And if that's the case, you just have to accept that and look for the next best idea, because the only ideas that are actually good are the ones that have a chance of being implemented. Now, I'm sorry if I'm trashing people a bit too much here. I don't actually think this is a good idea. I don't actually think it is. I just want to say, like, it would never get off the ground politically, and because of that, we don't even have to spend too much time discussing it. But also, yeah, I believe we should be able to independently manage our consensus, because we can define our consensus to be what's best for us, but we can never have Ethereum define its consensus to be what's best for us. And obviously, like if we use Ethereum now, we don't have to stay with Ethereum. We could tomorrow move to Ethereum for consensus and a month later do our own consensus again. We can choose. But yeah, I do believe that we are competent and able enough to build our own solutions. And I believe we can find better solutions, such as the proof of stake finality layer, because that's effectively what Ethereum would be. Ethereum would just be a finality layer. You publish a block onto Ethereum, it's the first one that's observed, it's valid. And it's using Ethereum's proof of stake consensus in order to agree on which block appeared first. If we do a proof of stake finality layer, it's about the exact same thing. It's just we decide who the validators are instead of using the Ethereum validators. And there are trade-offs to that, but I think it will be better in the long run.
It's cleaner, like in the sense of system design. It's a more appropriate architecture that's like self-contained, and it, like in an idealistic sense, you would say, hey, either we can design a system that's robust internally, or we can't, right? Like that's like, and again, in an ideological sense, to have to rely on another network to sort of like keep things from going awry, that's not as ideal as you would prefer. So if it's an option that might that could reasonably plausibly help, then it should probably be explored first.
Yeah, and that's why it's in the list, but I don't actually think it's worth too much further discussing, because we can include it and we can discuss it for 5 minutes and we can see why it isn't a good option and we can move on.
Now, how about other, hybrid proof of work, proof of stake systems? I know the finality layer is a type of one, but something like what Xano's doing. How about those? Is that somewhere? Where is that on this list?
That's under multiple block production algorithms, because as I understand it, Xano is just using proof of stake to decide who can produce a block, and they're not actually achieving Byzantine fault-tolerant consensus with it, at least not any more than Nakamoto consensus is allegedly Byzantine fault-tolerant.
So what is your take on that as an option?
I'm not a fan. I think protocols which have multiple ways to produce a block, like multiple proof of work algorithms, have consistently been attacked and failed to work successfully. I'm not saying Xano hasn't done a good design. I'm not saying Xano isn't better off for their design. I'm just saying that I don't support multiple algorithms to produce a block, because I believe it is going to lead to more complexity and problems than benefit.
Okay.
And if I'm understanding correctly, the worst that could happen with a finality layer like this is that if there's some sort of split or malicious, you say 34% of stake is offline or malicious, that's just delaying the finality of a block. It's not like we're not producing blocks. It's not like we're getting 51% reorged. It's more so that we're just not getting finality.
Right.
For the period where the finality hasn't been closed, you could still hypothetically reorg in that sense.
Right. And the other thing, of course, I'll note is one of the reasons I don't like proof of stake for block production is because we're biting the bullet on proof of stake, but it doesn't give us finality. And if we don't have finality, I'm like, why are we biting the social bullet of proof of stake, but not actually getting the benefit?
So
don't get me wrong, they might argue that it's harder to attack and harder to do reorgs, and that practically it allows reducing the 10 block lock. But right, if the finality layer is compromised, it would just stall finality. But that has the side effect of if we move from the 10 block lock to a finality block lock, that all new outputs wouldn't be spendable for as long as the finality layer is offline, even if the blockchain does technically keep ticking. And also, you should not handle transactions in those blocks because they could be reorged out, and everyone should move to just handling finalized blocks.
Okay, yeah, that was kind of my follow-up question there, because I see you have listed as no under multi-block production algorithms for allows reducing 10 block lock, but
it changes the analysis.
Could.
It doesn't fundamentally change which analysis we perform. We would still do the math on what percent of hash power you need for what likelihood of a reorg. And here it would no longer be what percentage of hash power, it would be what percentage of hash power or what percent of stake or which combinations of the two. But the math is very similar. And we can argue it's practically much more difficult, and I'm sure the Xano guys can tell me I'm wrong, and here's all the reasons why. It is a new analysis, but that doesn't change. It's not introducing any sense of finality. It's just making reorgs, if anything, more difficult and potentially a 10 block lock to, an 8 block lock or a 6 block lock.
Okay. We do have an XMR chat. Logically minded tipped $1. I like the finality layer proposal. It is similar to the design adopted by eCash, Bitcoin Cash Fork, founded by Amory Secht at Deadlinks, BCH founder. And after Bitcoin Cash got 51% attacked. It'd be great to have it on the show. Yeah, I don't know, Luke. Are you familiar with that implementation?
I am not familiar with eCash's design of a finality layer. I most remember Zcash's design of a finality layer, for which we obviously would have a lot of similar goals. Zcash has been doing their own work on such technology for the past year or two. I think largely because they do have a mining pool, which is so far benevolent as far as I know, but does have 51% or more than that. I'm not sure if they still do, but that at least was the case at the time. So they had a much more urgent need for it. But I do know that Zcash has been working on this problem and has done a lot of great research and development on it, and that's the one I'm most aware of.
Okay. And are there things to be learned, implemented from what the work you're doing with Sarai that would kind of come into play here with the finality layer?
Yeah, it's actually a humorous anecdote I give 2/3 of the way down the post when I comment on the finality layer.
Yeah,
Sarai actually does operate a finality layer. The Sarai code base, when it indexes Monero, it sees that a Monero block has 10 confirms and it starts to handle it. And the first thing it does to handle it is it talks to all of the other Monero validators for Sarai, and it makes sure that they all agree on it in a Byzantine fault-tolerant process. And only once they agree on it, and that they agree that this is the only Monero block that they'll handle, do they move forward with actually handling it. And then those Sarai nodes will refuse to reorganize off of a block that Sarai has finalized. So Sarai does internally have a finality layer, and honestly, a lot of the cryptography and development done for the Sarai code base could be applicable to a finality layer for Monero. I propose a way to have private stake transactions. We arguably don't need them to be private because, FCMPs, you just make one more hop, arguably. But if we do want private stake transactions, we would have to encrypt whether or not a transaction is a stake transaction or not. So that when validators rotate, they can decrypt the sum of the stake transactions. And that way they can find out how much total stake is in the system. So they wouldn't decrypt any individual stake. assuming that they're honest. But for stake transactions, they would decrypt the total stake. Or if they're malicious, then yes, they could decrypt staking transactions alone. They could not do anything to normal transactions other than identify them as non-staking transactions. But in order for that to happen, the validator set would have to create a threshold decryption key. And my work on Sarai has a proposal for a scheme that would be really, really great in that slot.
Awesome. Well, that's a nice coincidence there. So what do you see as kind of being the odds that we do move forward with one of these proposals? Obviously, finality layer seems like top choice here, but if not that, something else. How real is this becoming, and how long would it potentially take to implement something like a finality layer?
I do think the finality layer is the best long-term goal, and that we could get prototypes up quite quickly. But to actually get something robust for use case and to get the community on board and to get it integrated and shipped is a much longer process, and it would be a couple of years. I think Tevador's proposal could likely be done much more quickly, but it's arguably too much of a risk given our current distribution of pools right now. Like if no pool had more than 25, 30%, and we knew that like 80 to 90% of hash power could run their own node and carry over, which we could see not even by, we could see that just by, P2Pool getting 51% of hash power. If P2Pool had 51% of hash power, I don't think there would be an issue with adopting Tevador's proposal. But factually, right now, P2Pool does not have 51% of hash power. And because of that, we don't know how much hash power will run their own nodes and carry over. So I think Tevador's proposal would be a lot quicker to implement, but it may be too unstable to do right now when it could tip the scales away from the larger mining pools or directly into them.
At what point do you think we need to become more vigilant than we already are at this stage, where it's goes from code yellow to code red?
I think right now we already have a mining pool with 40% of hash power, and as I said, that's a very scary number. But it's still, they would have to get 50% more hash power than they currently have, assuming no one switches sides. So I think what we're currently doing in discussing options is good. I do wish that we had started this discussion earlier, because obviously we're starting the clock now. If it takes 2 years to develop a solution, it takes 2 years. If we started the discussion earlier, but I think even on past conversations I've had with you, Doug, I've said I think like Monero would ideally adopt a proof of stake layer. It's just, I don't think the community would ever go for it. And I think it's only now because of this and because of the increased vigilance we have in response that we are finally discussing a potential proof of stake layer with positive reception, with openness to the idea.
So I know you're saying something like Tevador's solution is probably not wise to implement right now, but I'm also hearing you saying, even if things do get more dire, it's going to take at least 2 years to implement the finality layer. So would there have to be some kind of interim solution we do, something that we do to kind of thwart things, or at that point we just have to see how things play out, how the game theory plays out?
Yeah, the Monero project isn't going to get a hard fork within the next month, and there isn't going to be, unless there was truly an absolute emergency, aliens are invading, the Monero project isn't going to get a hard fork in the next month. And honestly, I think the only solution we could discuss within that immediate in a time frame is using Ethereum, because we technically could write such a solution in a few weeks. That doesn't make it a good solution. That doesn't make it worthwhile. It just acknowledges it's possible. But when we're discussing a reasonably deployed hard fork and proper discussion around it, we haven't even started shipping binaries for the FCMP++ hard fork. And because of that, we could include consensus changes in there. And maybe Tevador's proposals would be efficient enough because Tevador already did a proof of concept. Maybe they would be efficient enough to implement. We could shove it in there, but that would still be multiple months out. And that requires the community and the developers in the project agree now it's worth doing. But as I said, it would shake up the scales, and we don't know how it would shake up the scales, which is a very big impact. And unless P2Pool has a much larger percent of hash power, as in P2Pool is the top mining pool, and we know that hash power will carry because everyone on P2Pool does run their own node, I'm not sure we can reasonably safely recommend it.
So everybody turn on your miners. That seems to be the best option right now. Row. Just gotta row through the storm here. I don't know, Buddy, Tux, you guys got any other things you want to bring up on this topic? And then I wanted to ask Luke while we have him before he goes, just kind of his latest take on full chain membership proof progress, and the I think we saw the testnet alpha is getting implemented. But before we move on to that, anything else on this topic?
I was curious about the TEE block templating. I noticed it's been crossed out and withdrawn due to fundamental issues. My thought on that was, I know TEEs are inconsistent across platforms, and I imagine a lot of mining platforms might not even have TEEs. Is that part of the reason why it was withdrawn, or is it totally unrelated to that?
Yeah, so it was a very interesting idea. It was basically, obviously, malicious miners can exist.
Yes.
And what if we use TEEs, which are not perfect? They are broken frequently. But there's different levels to it. Most frequently, only their confidentiality is broken. So you can peek inside the box. To break their integrity, to make the box do something other than what it's supposed to, that is different. And that happens less often. So the proposal was, can we use the integrity of a TEE, which is broken less frequently, but is still occasionally broken, to have most Monero nodes most of the time not behave maliciously? Like, yes, they still can behave maliciously, but only if they can break their TEE, which maybe happens once every year or so for integrity. For confidentiality, it's much more frequent. And if the TEE is broken, they don't get control of the network. It's just back where we are today. So that was what the proposal was. Can we use a TEE to try to force people to behave honestly most of the time? And if the TEE is broken, like it could be about once a year, once every 2 years, specifically for integrity, we're just back where we started. No harm, mostly no foul. Unfortunately, there were two different issues that kind of killed it. The first one was a network topology issue. You basically had to be directly connected to every miner. Because if you're indirectly connected to a miner, if you have 1,000 nodes between the two of you, then using those 1,000 nodes in the middle, the attacker can slow them down or speed them up. So they can make the 1,000 nodes take 10 hours to get a message across, or it can make it only take 1 second to get a message across. And because the TEE will ensure that messages do get delivered and that they are fairly handled, that doesn't change that a miner or an adversary who can delay it by 10 minutes or 10 years can still effectively turn off receiving messages and ensure that they never get transactions, and therefore just mine empty blocks as much as they want. So that was one issue, and the only real solution is to directly connect to miners, because if you're directly connected to miners, you can make sure that they're handling your messages without taking 10 years to do so, that they are responding in just a few seconds, and that they are receiving your broadcasted transactions and are handling them. Not just that they will receive them and will handle them at whatever time they want to. The other issue was how fundamentally it doesn't stop 51% attacks. And because it doesn't stop 51% attacks, it kind of helps when you only have a minority of hash power. But if you have a minority of hash power, none of these attacks matter anyways. If you have a minority of hash power, you can't censor transactions. Yes, you can mine empty blocks, but eventually there will be a block you don't mine, and the block you don't mine will include transactions once again. So we don't need all of this complexity for solving a problem that already is just an annoyance and not a fundamental issue. It does potentially gain relevance again if we do have a proof-of-stake finality layer. If we have a proof-of-stake finality layer, then we do stop the 51% case, which is the side that the TEEs couldn't handle. And then potentially the TEEs still make sense just to build a fairer and more secure network. But it wasn't perfect, and it's not worth the complexity at this time because of issues identified by and in discussion with Justin Berman, who was really critical in breaking it down.
Yeah, I have a question about right now we're seeing Cubic mine empty blocks, and how much discussion has been had about how that could break dynamic blocks, and if any countermeasures might need to be taken there.
Oh, I'm sorry. I don't personally have commentary on dynamic blocks. I mean, obviously, people are tracking how many blocks Cubic is mining and the impact. I know it's alleged that they're trying selfish mining. I've heard Sec1 comment that they've lost more blocks trying to play the system than they've won blocks. Like they're not actually doing it well or properly or profitably, according to Sec1. But I can't comment too much on the dynamic block considerations personally. Sorry.
That's fine. It's just kind of a stray realization that these empty blocks are going to affect the dynamic block calculation for sure.
We do have some super chats. Libertad tip $10. Thank you, very generous. Shout out to Luke. He's the best. Super glad to see him continuing to stay engaged with the project and the community. His technical contributions can't be overstated, but I appreciate him engaging with the community to help explain these complex topics for sure, for sure. More than explain, contributing and giving the ideas that we need in these moments. So yeah, Luke, obviously, we all thank you and appreciate you coming on this show actually to talk to us out in the open.
Thank you.
Another super chat here. Shortwave surfer tip 10 cents. How do we incentivize P2 pool? Yelling, please use P2 pool clearly doesn't work. Any ideas? I believe this was discussed, right? Right.
If we adopted Tabador's proposal to effectively require miners have a Monero node, well, that's probably the biggest barrier to entry to P2 pool now is that you have to have a Monero node. So if we require all miners have a Monero node, suddenly there's no reason not to use the mining pool, which requires that. But that would throw all the hash power in a jar and shake it really, just shake it all over and see what percent happens to fall out and where, which is the issue with adopting that proposal right now.
I have some dubious speculation or proposition here. It would be something along the lines that anything which increases complexity or difficulty of running, of mining, is either going to cause hash rate to centralize into pools or cause us to lose hash rate. Like anything that increases complexity on the user-facing side is going to do one of those two things.
Right. Here, the concern is that it would cause us to lose hash rate, and the concern is who will be left standing.
Guys, anything else on this topic? Otherwise, I'd like to get Luke's take on the latest with full chain membership proofs. And then we can run a viewers on stage. I don't know if Luke can stick around, but people will jump up, and I'm sure we'll continue to discuss the these proposals here. So I guess I'll go ahead, Luke. Can you provide us any your take on where we're at with full chain membership proofs and how things are looking?
Yeah. So step back several months ago and haven't been the most up to date since, but obviously there's a testnet starting soon. The performance is looking really good. We recently held a contest to optimize the Helioselene library in the divisors library. The Helioselene library is the low-level cryptography that the entire full chain membership proof is built on. So I think we got 20 to 30% performance there, which means the entire scheme should be 20 to 30% faster. Really great, worth the money. And then for the divisors library, that's used for provers. And that actually was sped up 30 times, which is really incredible for us. So now proving full chain membership proofs should be much, much faster. So yeah, all moving forward, testnet soon, wallets integrated well enough, we can actually discuss that. It's something I'm very excited about.
Fantastic. So what's current timeline, would you say, with actual full chain membership proofs going live at this point?
I would say I'm not the best person to ask about that.
I gotta ask the questions. I gotta throw them out
No,
there.
it's all good.
All right. So yeah, this is we covered a lot as always, Luke. I greatly appreciate you taking the time to be on today. It does feel it does. Monero is constantly under attack. Here we are. We're excited about full chain membership proofs. We've never been closer than we are right now. Everything seems to be working out with that. And then, bam, we're getting hit with this other issue here, now having to bolster the network against 51% attacks. And I'm sure once we achieve that and fix that, there'll be something else. Maybe quantum attacks will be the next thing. Who knows? I know you've been very vocal about that. Is there anything you want to mention about that? I mean, is that what do you see as kind of Monero's biggest issues right now? Obviously, I think you would probably put this 51% attack thing at the top of your list. But yeah, how are you currently ordering things in your mind in terms of how we keep moving forward with Monero and kind of increasing our odds of success?
Yeah, obviously we can say 51% attacks are a very immediate concern because someone is trying to force the issue and acting very important despite the fact they have yet to force the issue and have yet to demonstrate that they could force the issue. But they're generating enough noise and enough marketing campaigns about it that we're discussing it. So obviously that's a very current topic. But one of the things I called for after full chain membership proofs was actually a hold on future elliptic curve cryptography development. I think with full chain membership proofs, what we'll see is that the privacy is good enough, the speed is good enough, and the features are likely good enough for the relevant time span that we should move to the development of post-quantum technology. Because the thing about post-quantum technology is we will have some years to do it, but it will take some years to do. By the time someone does announce a quantum computer that can't yet break Monero, but can break Monero in 2 years, by the time someone actually does have a real-world demonstration and starts breaking smaller elliptic curves that might have been used, in the 80s, it will be too late to move forward and develop post-quantum technology for when quantum computers that can break Monero's current cryptography exists. So it's something that even if we don't see the threat directly in front of us, even if we see it out on the horizon and we don't know when it will get here, it's something we have to have ready by the time it gets here. And that's the very tricky and annoying thing about it, which is why I called for holding future elliptic curve development and moving to post-quantum development. And obviously that might not be true. If we have to do the private time lock scheme, then we will be modifying the full chain membership proofs to incorporate time locks, and that could enable the finality layer, which may be more pressing of an issue. But yeah, I think long term, we should be discussing both a proof of stake finality layer and we should be discussing post-quantum cryptography. one of the things I actually really like about my proposal for the consensus algorithm for the proof of stake finality layer is that it does only use post-quantum cryptography within itself, because it's solely predicated on hash functions. It's not predicated on like elliptic curve signatures or anything. And because of that, we wouldn't have to rewrite it in 5 years if a quantum computer comes around.
Two birds with one stone.
Mm-hmm. It's also
right,
just independently a really great proposal. They use hash functions alone, and they note it's for the performance of it. But it also, as a byproduct, offers post-quantum security.
Fantastic. We do have a comment here. Luke, Tevador's proposal can be done if it requires only the transaction plus block hashes. That's about 70 or 7 gigabytes of storage needed. I don't know if you're understanding that.
Yeah, I don't actually immediately know what data Tevador proposed hashing or the final results. I can try to on the diskbase. I can try to pull it up. But my comment was more what Body said earlier, is that any complications to the mining process will either encourage pools or encourage less miners. And here, this doesn't encourage pools. The entire point is to discourage pools. So it runs the risk of less miners. And if you're saying it's not 120 gigabytes, it's 7 gigabytes, yes, that might be a lot more accessible, but there's still the risk of it putting all the miners in a bag, shaking it up, and seeing what falls out, and we don't know what will fall out where.
Alrighty. All right.
But thanks for the correction or potential. I'll have to look that up and see what's up.
All right. Yeah, I don't know if anybody's been paying attention to the Monero Research Lab this morning. I don't know if there's anything new coming out of that from, other than what we're talking about here right now live. I assume there's no new insights given the cubic attack stuff. But if anybody wants to jump up on stage and talk about this more, you're welcome and encouraged to. Luke, I don't know if you're able to stick around. Actually, we got to run the news segment first. If you can stick around, great. If you can't, we understand. And yeah, once again, greatly appreciate you taking the time to come on here and talk to us. And I'd love to see that you're involved as always. So
I can probably stick around another half hour or so.
Okay.